presentations that are slotted for tomorrow, because if you look at the program for tomorrow, we are supposed to start very early. And we would like to give you some more time to rest. And therefore, if we can handle some of the presentations for tomorrow, then I request you to come at 8:30 instead of 8 as is indicated in the program. So without wasting any more time, I will request Dr. Saini and the rapporteur to take over. Dr. Saini.
Thank you very much, Mr. Chairman. Before I call the first speaker, I want to make one announcement. Some of you may be knowing I was recruited by IBAR to produce a book on 75 years history of ISTRC. So we are in the process of doing that, but we are short of pictures. So anyone who has got old pictures of ISTRC meetings or even research, please send them to the Secretariat. We will acknowledge each and every picture which will be published in the book. So please, if you have any old pictures, please send them to us. Thank you so much. Let's move on and listen to Ibrahim on population structure and genetic diversity of Pelpelis in Congo. Ibrahim, please. It's online. Ibrahim, can you hear us, please?
Can you hear me, please? Can you hear me?
Yes. We can see you. Can you please proceed?
Yes. I wanted to
share your slides first, please.
Is my screen open? Hello?
Yes, please.
Is my screen on?
We can hear you, but we can't see the slides.
Hello? Yes. Okay. I'm Abraham, am I okay? I'm presenting on population structure and genetic diversity.
Please share your slides first, Ibrahim.
Can you hear me?
We can hear you, but we can't see your slides.
Okay. I would like to share this thing. Okay. Is it okay now?
Yes, please. Go into presentation mode.
Hello?
Please go into presentation mode.
Yes. Okay. So, I'm Abraham, am I okay? I'm presenting on population structure and genetic diversity of Lucina Pascapes, Sosolanto from Congo, Brazzaville, with challenges for control strategy. I'm from Marengo University, Faculty of Science and Techniques. So, to transmit the deadly human parasite trypanosoma Brucei and other trypanosomes that cause animal trypanosomiasis. But the knowledge on genetic diversity, population structure, population size, gene flow are prerequisite for designing effective CC control. Based on morphological and morphometric parameters, it has been clearly identified that the two main species which cause trypanosomiasis in Congo-Brazzaville are Glossina fuscapes, and Glossina fuscapes and Glossina palpalis. But the distribution, the local distribution, is that in the south we found Glossina palpalis, and in the north, from the Cameroonian and Central African Republic border to the Plateau Mateke, that is populated by Glossina fuscapes species. But this second species is questioned about the identity because it has been severally published that it might be composed of several subspecies, among which Glossina fuscapes, Glossina quercensis, and Glossina, the Glossina fuscapes have several subspecies, but all these informations are limited, and we cannot have a clear view of how to proceed if you want to move. Limited publication information on these parameters, including migration pattern for Glossina fuscapes in the Congo-Brazzaville. So these are the three main areas where we did the collection of cessation flights: in Bomassa, around the Cameroonian border, and in Mbuemba, in Plateau Mateke, and also in Talangai, around the same area, which is opposite Wamut foci in the DRC. So we collected 288 samples from the three main populations, among which we got 9 subpopulations, by which then we extracted our DNA following the protocol described previously by other scientists, as my predecessor had just described it. And then the product were sent to microgen for sequencing. And then sequence analysis were done, and we used PopGen to validate our data, and we tested the early equilibrium and the linkage disequilibrium. So for the heterozygosity, we determined also the expected heterozygosity and the observed heterozygosity. We got also the allelic richness, and also we got the information about the fixation index. So we used Harlequin to confirm all this information according to what is here, and then we got more information on gene Alex, and we used the FSTV to get the discriminatory DAPC in version 3. Then we use Harlequin to get AMOVA for population differentiation and to confirm in gene Alex. So we got also the relatedness of those the three population individuals, and we got the migration pattern as well as the estimation population size. So for the results, for the test on the early equilibrium, we got two markers which show significant differential for early equilibrium in the three population, and two others which are shown here show departure from random mating in the two population, which is Mbuemba, BMB, and Talangai, which are all found in the Plateau Mateke. And we got also high polymorphic allelic richness, and fixation index got all significant as well. So the microsatellites are independently inherited in the tree population after the collection by the host. So the mean low side were on 0.07 to 0.078 and 0.14 to Umasa, Wemba, and Kalale respectively. So we detected 5 of the 45, 11%, UN using the following pairwise comparison. So we also got high and almost similar in the tree population heterozygosity. They observed, which the mean was 0.65, and the highest value in Wemba and Tanangai were 0.72, and the lowest 0.65. So the expected was high in all the localities, with a value of 0.77 to 0.78 in Bomasa, and expected heterozygosity was 0.77. So we found that the allelic richness were all superior to 11 in the three populations. So the pairwise FST was between 0.03 to 0.06, indicating little genetic diversity, differentiation in all sites. Where between Wemba and Omasa, the FST value was of 0.06, and Wemba to Talangai 0.04 and 0.03 in between Bomasa and Talangai. So this is the FST value as we got, and all the various components were significant. So the overall differentiation detected among the three populations groups were all significant, and the variation, most of the variation were 4.77 among the three populations, and the 3.35 of the variance within population. Most of the variance, the variation were within individuals. So we tested also the isolation by distance, and then we realized there is no isolation by distance between the sampled areas. So the population structure, the population structure, we found that tree cluster, when use the same method as described previously. So we got the tree population, which is Bomasa, Wemba, and Talangai, the cluster to tree cluster. And then we found that we identified tree cluster as I said, and we found that there is admixture of flights between the three clusters, suggesting the ongoing gene flow. And Bomasa show more distinct population and more homologous. And we found within that category, few flights from the two populations being admixed with the Bomasa populations. So we realized also that there were a lot of migration between the three sites. Although the Bomasa site is 400 kilometers away, but we can see migration of individual flies from Bomasa to double direction to Wemba and to Talangai lower in the Talangai. So these are the indices, the diversity indices, and also the relatedness of the individual. So we got the head-shaped frequency distribution for the bottleneck, and showing significant heterozygosity deficiency in all populations. This indicates the absence of any genetic bottlenecks among the sampled Glossina fasciculus population in the recent past. Each population have a high level of genetic diversity, pointing out the ongoing immigration and global mating among the population, despite their long distance separated away from the Bomasa site in the plain north. So we also noticed the low differentiation, which indicates the ongoing exchange of allele among the three populations. The admixture of plants between the two clusters suggests ongoing gene flow, as I already mentioned. There were no significant reduction in effective population size. The number of reproductive migrant per generation, which in the other localities are even extended at the infinite size of the population. So this characterizes all Lucina fascicates for the recommendation. Sorry, I recommend that for considering all the movements of the successive flight between the three movements and the admixture of cells in their structure, as well as the ongoing gene flow, despite their long distance. We suggest that we should characterize all Lucina fascicates species countrywide. If Lucina fascicates sassolando, species complex issue which we will talk about on our second presentation, or it is the cryptic taxa. So we suggest also the CSA control effort should be established. We should establish a barrier using proportional tools such as target or traps between the separate location as a way to minimize the rate of gene flow between relations. Thank you very much for listening.
Thank you, Abraham. Abraham, we note that you have another paper submitted with a very similar title, 107. Would you like to present that one, or we cancel that one?
Okay, I can also go for that one. And I have to share again.
Since you are online, can you proceed with that also?
Is now, in the first paper, we use microsatellite markers, as I said, on 10 microsatellite markers. But because the characterizations, still the planning issue here in our case, having a problem to, okay.
Okay, so
I used my mitochondrial DNA now to get the information from the root stem. Sorry. Okay. Okay, so the second type is the screen share. Okay. Yes. Okay, on the second paper, it's on population, the phylogenetic relationship and diversity of Glossina of the Palpalis group now from Congo, the challenge for the same issue of the control strategy. So the identity of the existing taxa in Congo, as I mentioned earlier, Glossina fascicates sonata in Congo remain questionable. Why the Glossina palpalis is well known and is they are habited in the southern part of the country. And this was based only on the morphological morphometric classification alone. And this, we think, is not sufficient to confirm as a local level as we want to move forward according to the AU recommendation of the eradication at the Pan-African level. So we thought it was better for us, first of all, to go to the molecular level to identify those species and confirm whether it is really Glossina palpalis in the south or and Glossina fascicates in the north, as I say. But this has been consistent for palpalis over time since independence, and the fascicates group still have an issue. So this is the distribution, as I said. And just in the southern part of Brazil, which is the capital city of Congo, it has been demonstrated that there was an overlap of Glossina fascicates, which the subspecies was the Kwanzassis, which was the occupant of that habitat, was pushed away by the Glossina palpalis coming from the southern part of the country. And this, we thought, will complicate the taxonomic status and the dynamic of these two taxa, because the country has undergone so many issues, including the civil war, which happened 2 decades ago, and with the movement of population around, so as the disease still there in cases which are declared in some hospitals, so we realize it's better we realign our taxonomic standard countrywide before using molecular tools before moving ahead. And this was suggested by Tua et al. In 2006, when he suggested that because this species is assumed to have subspecies, this is now the issue of the species complex of Glossina fuscapes. So he suggested that because this subspecies is well known in Uganda, where Glossina fuscapes is well studied and documented at the molecular level, we should use that example now to compare our species, which we have here, with that one which is already known. So we use molecular mitochondrial DNA marker, which is the cytochrome oxidase 1 gene, to differentiate among the two closely related species, which are Glossina palpalis and Glossina fuscapes. And there has been no attempt today to carry out such identification at the molecular level, as we want to move on to establish the control strategies in the country. So these are the markers which have been used. So we use the molecular markers, mitochondrial markers, with the opposite, with the what I've just presented on nuclear marker, which is not the satellite. These are the primer we use, using this chart flow to evaluate the genetic diversity indices and also the network within to join the haplotype, to find the haplotype within the same population in the tree population, including the Glossina fuscapes, palpalis for their relationship. So this was based on male genitalia shape for the internal cluster, as described by Lake in the book, as the manual which was shown previously. So we use that one to try to put our species in the packet. So this was done in Bomasa, Talangai, and the Gabe corridor, in Wemba and Talangai in the Gabe corridor. And this, for both Kosovo, especially now for Glossina palpalis, to find a resolution with notification of palpalis tax. So this is what has been done. We realized that we were able to target or to amplify the 570 base pair molecular size of this as described, and also for the Glossina fuscapes, which we say we prefer to reach to the species Sassolando. Then for the Glossina palpalis, we got 850 base pair. So this presence of putative Glossina fuscapes in Bomasa, Wemba and Talangai has been demonstrated. So the palpalis in Bokosovo in the south was only based on this genitalia identification. This result confirmed the presence of both Glossina fuscapes and Glossina palpalis in the Congo, which was good state already. So we identified GPP, the high similarity with G fuscapes, using the blast with 98%, 98.60, 98.95, and 100% for Wemba. So with specific primer sequence in the baseline, we, as described by Feldman et al. So these are the indices we got for genetic diversity. So we were able to get this, we realized that we got 988 haplotype from Wemba, 987 haplotype from Talangai, and Bomasa 88. So these are the number of segregated sites. We got all the information, and then as well as the p-value of when using the neutrality test and the goodness of fit. the neutrality test, we use Tajima-D for historical background of this Seisei population using mitochondrial DNA, and we confirm with the forces as well as the R-wing p-value. So then for the relationship, so we realize so many mixed up as the same as what we have obtained from for microsatellite. We also realize that we have clusters which have mixed haplotypes, including the species which were got from ISCTRC for Glossina fascapes, and the Glossina palpalis from Nigeria, and NIGR from Nigeria. So all this mixed information brought us the idea to say that the description is more, there is a mixed up. So there is also a mixed up haplotype from 3 populations. As it is shown here, you can see the rounded cycle here, which represent the haplotype, which are shared or other single or other shared between the 3 populations. And this was confirmed using the phylogenetic tree of this haplotype. Then we say because the palpalis has low difficulty in identification, so we decided now to make the barcoding of this Glossina fascapes palpalis. So we use the bolt to identify this. So we confirm the presence of the two species as previously described, with differences, and this admixture confirm also an expected natural distribution of the Congo. And more interestingly, the Glossina palpalis from Bokosongo, which is in the southern part of the country, has also clustered together in some sequences with Glossina fascapes from the gene bank, as this accession number here shown. So, and they also share the common ancestry with Glossina fascapes sequences, Glossina fascapes martini and Glossina palpalis from the neighboring DRC as by this haplotype, by this accession number in cluster 3. So this makes the situation more complex, and for the time being, we cannot say exactly which species is especially located in this part of the country or not. So this is, as I've already said before, the mixed haplotype of this species with other species which are not supposed to be clustered in that in this cluster, which bring more complications. So we can say that the presence of several Glossina palpalis in Tanangai, which is in Plateau Bateke, is a signal of ongoing dispersal among Glossina species, subspecies in Congo, as we early demonstrated using microsatellite marker. And this would also be perhaps of the favorable habitat for this species, where they can find easily the black meal, where there is a lot of activity of, a lot of activity. This, we can confirm the ongoing migration of the Glossina palpalis. So, this is what I've been discussing in the results section. So the most important thing is that this finding imply the misidentity of both Glossina palpalis here by Bokosongo 256 and this accession which are Glossina palpalis and not Glossina fascapes nacional. So this brought us to a conclusion, because in Mwemba, for instance, which is inhabited by Glossina fascapes, based on the 100% identity of the gene bank of Glossina originated from Uganda, as we say. We say, so in Wemba, we might be having species which matches with Glossina cascapes, but quite different from other subspecies such as Wasensis or Martini, which are not the case here, but are found in other. So the shareholder
Please conclude now.
That, and the challenge to confirm this subspecies is really urgent, and also the marker as the historical background show the expansion of this population. This makes the control strategy ahead more difficult.
Thank you.
Based on the genitalia. So thank you very much for your attention.
Thank you so much.
Good afternoon, everyone. Besides drug discovery, we are also very interested to know and understand how trypanosomes are so effectively infecting the host after bites. So there will be a little bit of immunology, so please bear with me, and understood you will be rewarded at the end of the cocktail.
Ibrahim, can you please unshare? Close your presentation, please. It's still there. Still close it.
The summary.
Ibrahim, please close your presentation.
Okay, so in conclusion, we can say that this
Unshare. Thank you.
We'll take over from there. So what we know from certified transmitters, trypanosomes, so metacyclics are inoculated in the skin together with salivary fibers. And these trypanosomes have to cope with several immune cells, several innate immune cells, most prominently neutrophils that are rapidly recruited. And so trypanosomes are quite motile and are able to avoid being phagocytosed and engulfed by these neutrophils. Next, please. Another immune cell, another innate immune cells are macrophages. And people that know a bit about immunology and trypanosomiasis will know that trypanosomes have to maintain a quite intricate balance between activating a macrophage into an M1 activation state or an M2 activation state. And I hope they can go to the next one. Okay. Oh, no, one back. Okay. Still one? Click. Okay. And so this is actually governed by interferon gamma and IL-10. Interferon gamma being an inflammatory cytokine and IL-10 being an anti-inflammatory cytokine. And so you can see that M1 macrophage activation is linked to pathogen or parasite control. M2 activation is linked to outgrowth of the parasite. So you can imagine that for a parasite it's beneficial to induce IL-10. So what we see if you look at transcriptome data of the skin of infected mice, so it's again a mouse model, and again preclinical mouse models will be important if you want to study this type of interactions. And so we saw indeed an inflammation in the skin, but very prominently a quite well balanced, where you see the two red arrows, M1 and M2 activation state. You also can see that there's quite well balanced between interferon gamma and IL-10 transcription. So, but you see the high IL-10 levels are actually quite surprising given infection with a protozoan parasite, you expect actually a better response, a stronger interferon gamma response. And this is because there's already a quite high IL-10 induction, which is done by the parasite. And work spearheaded by Benoît Steylemans from the VUB, where we collaborated, has shown that there's a protein called Q586B2 that is present in the early and late endosomes and very strongly secreted in the extracellular space, a bit like the aldolase that Stephen Odongo was talking about. And when we produce recombinant protein, we showed that this is a highly IL-10 inducing protein. So we went on to make knockout parasites, so parasites that lack the gene that transcribes or that it results in this protein. And so these parasites are much less capable to cause parasite outgrowth, as you can see, with a significantly reduced parasitemia. This is also linked by a lower capacity of these trypanosomes, these knockout parasites, to induce IL-10. So quite clearly, this protein is an important immune modulator, inducing IL-10, inducing M2 macrophage activation. So in absence of that, parasite is less capable to infect the host. Another cytokine that is getting more and more attention next to IL-10 is IL-27. So IL-27, we checked this cytokine at the level of transcript levels in different tissues, and in all tissues where you can find the trypanosomes after a tsetse fly bite, you can see upregulation of this gene. We also see in the plasma quite high levels of this IL-27. Then we used IL-27 reporter mice, and we actually have shown that the source, which was not very well known in trypanosome infections, is from myeloid cells, including neutrophils, monocytes, and dendritic cells. So what is the role of IL-27? So we had two complementary approaches to study the role of IL-27, using either neutralization with antibodies or using IL-27 knockout mice. And you can immediately see in red that there's quite nice congruence between the two models, where trypanosomes, in the absence of functional IL-27, are much less capable of infecting the mouse. This is actually the most strong phenotype that we have ever seen when we interfere with a host cytokine. Of course, this is to the disadvantage of increased pathology. This is also an image, so you know that Nick van Reet makes a lot of fluorescent parasites, but he also made some luminescent parasites. We have passaged them several times to the flies to have very good infections and a lot of metacyclics. You can see on the ear where the tsetse fly has bitten, and you can see quite clearly the difference between the non-treated and the anti-IL-27 treated mice, as well as the wild type and the IL-27 knockout mice. So again, showing quite clearly there's a big difference in onset of parasitemia. This was linked to much higher interferon gamma levels. So remember, linked to M1 activation. So again, in both models, but without any effects on IL-10. That's important. So it's an independent regulator of IL-10. So to recapitulate this part, so we know that in early infection, the trypanosome produces this protein, Q586B2, that stimulates macrophages to produce IL-10, become M2 activated. And then trypanosome infection also induces IL-27 that inhibits interferon gamma and M1 activation. So you can clearly see that these two pathways will trigger the M2 activation state that is important for parasite outgrowth. Now, using the same bioluminescent parasites as before, we also have looked at where are they going after the bite. And something that was very peculiar is that we see them very early on in the lungs, and they remain present in the lungs. And that has not been described before, although it has been described in sleeping sickness patients that some people suffer some respiratory problems. So we did some electron microscopy, scanning electron microscopy, and they're in the extravascular spaces. I will help you a bit. Here they are, in quite large proportions. And what we also saw is that these parasites produce a large amount of extracellular vesicles that are present as these beads on a string. This is also the first time that such EVs have been described in vivo, because it has been shown before in vitro. So it's known that these EVs are very important to modulate immunity, even to maybe communicate between parasites. So this was published in Nature Communications not long ago. We also had the chance to look at what the effect is of infection on the function of the lung. We used some very, let's say, the state-of-the-art measurement of lung function in mice, and we could see that this infection actually didn't have any effect on the function of the lung, which actually is quite compatible with the lung as being an asymptomatic tissue or reservoir where parasites reside. And that may be a crazy idea, and as an academician, we always can have crazy ideas. That's a lucky thing in our profession. So what we are doing now is sampling mice to see whether we can, based on breathomics, identify volatiles in the lungs or in the exhaled air that will identify an individual as being infected or not. So this may be sounding quite far-fetched, but a lot of people in my faculty are studying the discovery of volatiles as biomarkers for lung cancer and even for inflammatory bowel disease. So it's possible in the air, in the exhaled air, to have biomarkers of infection. So this is how such a profile looks like. So it's gas spectrometry in combination with mass spectrometry. And so at the end, we want to identify specific volatiles. And at the end, we want to make a medical device that looks a bit like this, something maybe some people have gone through before, like a kind of alcohol test where you actually collect an air sample and specifically detect alcohol, but in another case, another volatile, right? And so it's adjusted to the local situation. So I wanted to look for maybe people that are interested, as there are not too many hot cases left, and there's also a possibility to capture volatiles in a column, to store it, to send it, and to analyze it elsewhere, to have maybe someone who's willing to help us in getting the latest breathomic samples from the last HUD patients before it's eliminated. Then it remains me to thank several people and to hope that you're still okay.
Thank you very much for a very interesting paper. Let's move to effects of antibiotics on the survival of pupae. Boma, please. Is Boma here? Not here? So, okay, we can move to the next paper then. 410, identification of Cameroonian sassafly species. Steve. Steve, please. Steve is not here. Thank you very much, Steve. So, can we take Juliana's paper today? Is it possible, if you have loaded it or not? So then we can go to discussion. We have not loaded it.
Somebody's there. Somebody's online.
Oh, he's online. Steve is online. Is it Steve? Steve, if you cannot, can you try tomorrow? Because you're using your phone. While he's trying to connect, can we go to questions, please? Any burning question for John Hargrove? John made a very good presentation, so no questions. Questions for any other paper? Yes, please.
You talked about availability of hosts so as to mark the dispersion of Glossina. I would like to know, could there be a link between the observed dispersion and the availability of hosts, and what would be observed during the different seasons, especially the rainy season? Thank you.
Yes, please. Any other question for John Hargrove? Yes, please.
Merci. Ma question est adressée.
My question is addressed to Somalia on radiation. One first question, I'd like to know how they do their selection, because the 120 degree will not systematically give infertility. The second question is, he said the 120 will give something like 87% of fertility. Does he follow closely the flies? Because nothing says that the 120 degrees will push to fertility. Is there a mechanism for following if the induction of the radiation can touch other genes and bring about other kinds of resistance or something like that? Thank you.
Oui, j'ai une question pour Soumaïla également. Une petite question.
Question for Galia, a small technical question. I'd like to know what they do to make a differentiation. There are three groups of flies. How do they distinguish the three groups of flies? And how do they know that which fly has had mating with which fly?
I was wondering if you could clarify whether the fly movement is circular or is it linear? you talked of a movement of about 0.25 kilometer per square kilometer or something like that. I can't remember, but please could you clarify the pattern of movement of these flies? Thank you.
Okay, I think we can continue with these questions first. John, you have two questions, or three. John, you have three questions. One is on the dispersal of the flies, and the other one was on the link of biotic and abiotic factors on dispersion.
Okay. Let me just answer the first one on dispersal, and it's a good question. I was a bit naughty there because I'm thinking only of savanna-type situations, which I was modeling there. So there, what you're assuming a two-dimensional random movement model, just basically diffusion in 2 dimensions, so that you've got equal chances of moving in every direction. Now, of course, it's completely different in the West African situation, where the distribution of flies is essentially along rivers. And that's a different story. That's exactly true. So the answer is, I was only talking about a situation where you have diffusion in 2 dimensions. I hope that answers the question satisfactorily. And I haven't actually done any modeling of the way in which flies move in riverine, but other people have. So those ideas are out there. Now, I think the other question that Moise was asking, in fact, my understanding is that Thierry would be better to answer it. Those questions were from Moise. Hand over the mic.
So is it the question from Moise? Yeah, okay. So it was about the seasonality of dispersal. Probably flies do not disperse the same according to the season, but genetics cannot see that. It's an average we have. So it's an average of the all seasons.
Thank you. There are 2 questions for Somalia on radiation of the flies.
Okay.
Can you please answer those?
Yes. Pour la première question.
For the first question, the 120 degree which is given, is it when we expose the flies to 120, it makes it possible to sterilize them, and then it makes them to have a sterility which will be induced to females up to 95%. When the fly is exposed to 120, it makes it possible to sterilize the male, and then it is inducted to the level of the female. If not knowing, if we follow closely the flies, when we are doing radiation, the male doesn't go beyond a week on the ground. So the male will quickly die off, and even if this male mated with the female, a male which mates with a female with no reproduction, so there will be no population will remain in the nature to distribute genes. The objective here is to reduce population through this induced sterility. The Alan's question, in fact, the 3 groups of males are marked with a fluorescent powder, which makes it possible to differentiate the different 3 groups. So when we do the following up, we recuperate the couple, and the experience which lasts 3 years, we take the fly to the laboratory and couple by couple, and we keep the color of the male. That's how we're doing it to differentiate the 3 male groups. Merci beaucoup.
Yeah, thank you very much. My question also goes to Somalia about the gamma radiation. So with using the 120, yes, you induced a high rate of infertility, but the reproductive rate also reduced so much. So how do you compensate that? Because you're already, have very low mating success, but yours, when you use the 120, even the mating success was very, very low. Thank you.
And our rapporteur has one question, please.
Thank you very much, sir. My question is for Mr. Guy. When you gave us your talk, you made mention of the granulocytes, particularly you mentioned neutrophil, as being emasculated by the innate immune cells. But we are talking about a parasitic infection. My question is, what is the role of eosinophil in this particular case? Thank you.
Yes, can we start with Somali, please?
Okay.
I didn't understand well the question, but he was talking about the low mating. Is it that? That is to say, if the mating rate, which we use here, one male for a female, to ensure that all the females will be mated, and therefore we can assess the real impact of the flower. If it is on the ground with this low mating rate, before using this technique on the ground, we reduce the population. It's the real population on the ground which is targeted to be eliminated by the sterile male. In general, a study was done before. In general, for one wild male, we actually release 10 sterile males. That's how I got it. Merci.
Right? Or the role of neutrophils? Eosinophils, right.
Yes.
So what I can mention about eosinophils, it's been seriously overlooked actually. It's a cell type that we have seen in the lung to disappear completely. And so why it's disappearing completely, we don't know. But of course, if it's not there, it cannot do anything to the trypanosomes. So I don't know whether it's an active killing by the trypanosome or it's just dying from inflammation. We don't know. It's a very good question.
Thank you so much. We have two other guests. Let me ask our chairman to introduce them.
Start with this guy. 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 Start with this guy.
Okay, Steve, can you go ahead, please?
Please.
Thank you to giving me the floor. The title of my presentation is Identification of Similar Research Issues based on morphological development and nuclear ICS one polymorphism. Right? Right, please.
Steve,
Steve,
we can't hear you very clearly. I think you are using your phone. Can we postpone your presentation to tomorrow and use a laptop, please?
Right? In sub-Saharan Africa, especially in Cameroon, human African trypanosomiasis and animal African trypanosomiasis are the total of these diseases allow many people 663 cases were detected in Africa for human African trypanosomiasis and 2 million of cattle deaths every year for Anglo-African trypanosomiasis.
We can't hear anything. Steve, I think we take morning, please, because nobody can hear anything. Can you cut him out? Yeah. Send him an email, please. Okay, sorry, you want to industry first?
So, thank you, Mr. Moderator. Do we have Nur Shazina Ishak? Is he here? Do we have Dr. Wycliffe Ongeri? So Nur Chezina Isaac is from BioAngovax Son Bihisho from Malaysia. They have their stud, and we have requested that she only says hello to us. Any discussion about your products and so on, that will be reserved to the booth. Here, we just appreciate the support that you have given to the conference, and we encourage people to go and visit their stand. So please, if you can take the microphone and just say hello, the issue of the products and so on, we shall deal with them in your booth.
Thank you so much, honorable doctors and professor and all guests here. Thank you for inviting me to be a part of this big conference. Basically, I'm Shazrina from BioAngovax. We are a manufacturing company for vaccines, especially for small ruminants and aquaculture. Our aspiration and vision is small farmers all over the world by providing medicines that easy and simple to use, like we have here in our booth. You can come to our booth and explore. We have also our professor, the inventor here from our local agriculture university, Professor Zamri Saad. We are happy to share with you all our technologies, about our inventions. So looking forward to hear from you. Thank you so much.
Thank you so much.
So we thank you very much for the support and your partnership with the ISCTRC. Everyone is encouraged to visit their booth. They are one of the few industry partners that are still investing in the field of human and animal diseases. Once again, do we have Dr. Wycliffe Ongeri from SIVA? Looks like he is not around. He's also, that is one of the other industry partners that has been supporting the ISCTRC. Again, we encourage you to visit their booth whenever you have some time. Back to the moderator.
Ladies and gentlemen, when I was reviewing these papers, I came up with 2 slides yesterday. So to provoke discussion on the control, vector control, and ATT on the whole. So can I have the first slide, please? These are slides so that you can think over, and then we'll discuss them in detail tomorrow. If you look at the overall papers which are presented, hardly 5% of the papers are on vector control. There's no other paper on vector control. Lots of work still continues on mapping, distribution, disease levels. So the question is, why are national governments not undertaking long-term, sustainable vector control for elimination of the program? Our session today and tomorrow morning is biology, control, leading to elimination or eradication. So what is happening? What are the constraints? Is it because that animal trypanosomiasis and vectors are not a problem if human sleeping sickness is not there? Why is it not a problem? We have talked about in PAT, in other forum, we should think of One Health packages or holistic animal health packages. 10 years have gone. Why has trypanosomiasis not found its path in these animal health packages? Next slide, please. If you look at the toolbox, we have plenty of techniques, technologies, strategies available to knock down fly populations by 99% very quickly. It has been shown again and again. So it's not a question of techniques, technologies not being available. We have also talked about linking sepsis and trypanosomiasis control with SARS. Now we have the Sustainable Development Goals, but it doesn't appear there also. So what is it? Is it a funding problem? Is it donor fatigue? Is it a priority for governments or not? Is it our own priority? Of course, we have to keep our jobs. So what is it? Or is it that we as a community have to think differently now to undertake sustainable control leading to elimination or eradication? So I leave you with these thoughts. We'll discuss them tomorrow. Thank you very much.
Thank you very much, Dr. Saini. These are very provocative statements and questions that I think should serve as an appetizer for the cocktail. So if you don't have anything to tell the Fred you'll be sitting with, discuss these topics and let's have some feedback tomorrow. But first, let me congratulate the moderator and the rapporteur because we agreed that we are going to be stopping at 6, and now it's at 6. We indeed have done very well. The discussions, again, I want to take note of the energy that we are seeing coming in. Many of the people are presenting at this conference for the first time. Some of them, we have seen them for the first time, meaning that the fear that has been there that people are moving to other areas is probably an unnecessary fear. The emphasis, and I'm happy that Dr. Saini has brought up this issue of One Health. We really have to break the silos. A lot of the things, the kind of capacity we have seen here, if we use it and convince our partners who are supporting human health that we can continue accelerating elimination or sustaining the elimination status of the human disease by addressing the vector and animal components in a One Health approach, then we'll be able to come up with other innovative ways of mobilizing that funding. So let's continue thinking around that. I know I am the one standing between you and the cocktail, and therefore I'll not talk about anything technical from here on. Now we talk about where we are headed and who is going. I understand from the Secretariat that virtually everybody have said that they are going to go to the cocktail. So we are assuming that all of you are going to be with us. If you know that you are an exception and you will not be with us, you need to see the Secretariat, because we would like the buses to go in one direction so we have maximum time at the cocktail. But if you are not going, you will be taken care of. So, Secretariat, I don't know whether you have any other announcements. I just remind the regions, we are still waiting for Northern Africa to present their nominee. I know that the Central African region, you needed to go back again and look at your nominees. Please let's do so by tomorrow morning. So welcome to the reception. When we meet there, we shall probably have one person say hello, but it will be in the middle of you having fun. But then we remember, we still have some sessions tomorrow. Let's keep some energy so that we complete the conference, or we had the conference in the same spirit and with the energy that we have kept through a lot. So I'll just give back the microphone to the Secretariat, but before that, please let us give a very warm round of applause to the rapporteur and the moderator.
Thank you. Good evening, everyone. We are now just switching mode. We are transitioning from the science bit that started from Monday up to this moment. Before we break away, as per Professor's announcement, I just wish to take this opportunity to thank FIND for supporting Kentech together with AUI-BA in hosting you for the cocktail party. We are living here, moving to a restaurant. It's called Marina Seaside Restaurant. I reiterate that we welcome each and every one of you. We wouldn't wish to leave anybody behind. But in the event that you are thinking of getting back to the room, we also have transport for you. So with that, all roads will lead downstairs where the buses will be waiting for you. But you will be alerting us while we are down there if you wish to be taken to your residences. We'll show you the right bus to get into. Otherwise, thank you very much.